rule now. So essentially, we looked at composite functions in chapter 5. And the chain rule is a method for differentiating composite functions. It's also called the composite function rule or the function of a function rule. So I particularly like to look at it as a function of a function rule. And basically, it's just a rule that lets us differentiate functions where our value is not just simply x. So as you can see here in the chain rule, if a function y can be written as a composite function, where y equals f of a function, therefore our derivative equals the derivative of our function multiplied by the derivative of x. So let's have a look at how that works in a question. So what I have here is or question A, y equals 5x plus 4 bracket to the power of 7. And the way I treat this is I still use my standard rule, which is I bring my power down the front, multiply, and then I subtract 1 from the power. But because the value of my function here is not simply x, like x to the 7, or an amount of x to the 7, we've also got this constant here. We also need to derive what's inside our brackets here. So I need to derive what's outside the brackets, and I also need to multiply that through by the front value. So let's have a look at how that looks. So first of all, I'm going to derive my function in the middle, which is 5x plus 4. So if, let's say, let's just use the letter A equaled 5x plus 4, the derivative of A equals 5. So what I'm going to do is I'm going to bring that out the front. So therefore, my derivative of y, which was my original function, is the derivative of what's in the brackets. So that was 5. And then I just treat it as if it was a single term. So I bring my power value down. So 5 times 7. And then I keep what's in my brackets here to the power of 7 take 1, which gives me my 6. So I just simplify what's out the front. So 7 times 5 gives me 35, bracket, wrong number, 5x plus 4 to the 6. Cool. And that's essentially how I do it. So same sort of rules apply. All I need to do when I'm looking at a function of a function is I need to first derive my function that's in my brackets, and then whack that out the front as well, and treat, and then after that, treat it like just like a normal differentiation question. So here, we'll set A equal to what's inside my brackets. So 3x squared plus 2x take 1. So therefore, the derivative of my bracket is 6x plus 2. So again, I bring that out the front. That's my first thing. So now I'm going to be deriving my original equation. So therefore, y dash equals the derivative of my function, which was 6x plus 2, multiplied here by, and then I just treat it like normal. So bring the 9 down, multiply it by 9, keep what's in the brackets, which is 3x squared plus 2x, take 1 to the power of 9.